All right, Mr. Claxon's Algebra 1 CP class. I'm now going to very quickly explain the point-slope form and how to write linear equations in point-slope form. I really think that this is going to be very helpful to those of us who were struggling with converting sets of data in a table to slope-intercept form. This could really help a lot of us. It could give us an algorithm here and a formula for converting something to slope-intercept form when just given the slope and a point on the line. So the first thing that I say here is that point-slope form is y minus y1 set equal to the slope multiplied by the quantity of x minus x1. It's a linear equation whenever we fill in values for m and values for y1 and values for x1. That is a linear equation. It's the graph of a straight line. That x1, y1, that is, well, that's an ordered pair. Really, it's a given point as well. So anything given, that is the given point. So when we writing a linear equation, there's 4 different cases for translating from graphical to symbolic. We're trying to get from graph to symbolic here. When we look at a graph, we can very easily see the y-intercept and the slope, as long as it is a line that has integer values, or that's using very simple values to work with. So when we're given 2 points, we can identify 2 points. x1, y1 would be the first point, x2, y2 the second. Find the slope of it. Choose one of the points and substitute them back into the point-slope form for y1 and x1. So we substitute them back into this in order to see a linear equation. So the first thing I'm going to do with points 1, 2, 3, 4, I know, real original, right, is determine the change in y over change in x. And I just think of the change in y from 2 to 4 is positive 2. From 1 to 3 is positive 2. So I know that 2 over 2 set equal to 1. Which, if you did it the different way, if you did it by using the formula for slope, then you would have said 4 minus 2 over 3 minus 1, that's 2 over 2. It's still 1. If you see the next slide here, I go through to show you exactly how to write that first in point-slope form, and then I convert it to slope-intercept form. Like I said, that is what we were having trouble with, so I'm giving you a different way here. And you can see that I just use algebraic operations in order to do that. Gary, during class, said, Mr. Claxon, I didn't use 0.12, so he wanted to use 0.34. So down here, that is the example when using the other point. You can see they both give me the same result, y equals 1x plus 1, y equals 1x plus 1. So both give me the same result. It really doesn't matter what point you choose to put in there. Most people choose this one because it was x1, y1. You could have chosen the other one as well. Taking a look at another example here, we're using point-slope form. When we use point-slope form, we want to write an equation and understand point-slope form is going to be it is a form for a linear equation. I also convert that into slope-intercept form and then standard form for those who want to see it, because I really don't specify. I just say write an equation. An equation could be point-slope form, slope-intercept form, or standard form. I will be more specific on tests and quizzes, but understand the first thing I had to do was find the slope, and then I had to go through some basic algebraic operations to get to point-slope form. Add 10 to each side, and I get slope-intercept form, and then I solve for the constant in order to get the standard form. So when we're given the slope and a point, it's a little bit easier. Of course, you would want to use point-slope form. Now, you don't have to use point-slope form, but you can. When given the slope and a point on the line, I know that all I have to do is plug in the values. Once I substitute the values, you can see how they're color-coded here, y1 to x1. I can solve for y in order to get that slope-intercept form, which is what we were having trouble with. In the next slide, I show you how we use slope-intercept form instead of point-slope form to do the same thing. Some people say, Mr. Claxon, I like this way better. Well, okay, I will show you that way. When I'm specific and tell you that you can use any method you want to, then you would have the option of using slope-intercept form. So again, slope-intercept form here, they use point-slope form here, they both get to the same result, 3/4 x plus 11. In the next slide, that is what you were supposed to do for your homework. I recommend sketching a small graph to identify the points on the line to check your work. So writing an equation for a line with an undefined slope, which means it's what type of line? And an x-intercept of -2. So if you draw that line, if you sketch that line out, you know that it'll have an x-intercept. Undefined slope will tell you it's a vertical line as well. And you should know what form of line that we're dealing with there. So hopefully this will help you to understand the notes for standard form and point slope form of a line.